Hi everyone, welcome back to chemistry. In this video, we're going to start chapter 6, which is all about ionic and molecular compounds. So we're going to learn what chemical bonding is, why atoms want to bond in the first place, and how that actually happens. So it turns out that atoms want what's called a full octet. And what that means is they want to have 8 valence electrons in their outermost shell, or 8 electrons in their outermost shell, which is what valence means, is outermost. And the reason we call it a full octet is just because we have that number 8 here, and that we have that oct prefix, which lets us know that we have 8. So octopus is 8 legs, octagon has 8 sides, stuff like that. And it just turns out that we just see in nature that atoms with a full octet or a full valence shell are more stable. So if you look at your periodic table, remember we call the far right column, or the group 8A, we call that the noble gases. And the reason we call them the noble gases is because they're special. All the atoms really want to be like those noble gases, because those noble gases are very stable. So you could think of like the term nobility. They come from nobility, means that they have that status. So that's where that kind of comes from. So atoms really want that full octet because it's stabilizing. And we'll see kind of why that actually is in a little bit. And so in order to get those 8 valence electrons, and remember helium is an exception, right? Because helium, it has a full valence shell. But remember in period 1, we only have that S sublevel or subshell. So that S can only hold 2 electrons. So helium, even though it doesn't have 8, it doesn't have a full octet, 8 of them, it does have a full valence shell. So it's still just as stable, okay? Okay, so in order to understand why atoms might want those valence electrons and how they go about getting them, we need to know this term electronegativity. And you'll learn more about this in the future. We're just going to look at it from a very simplified perspective. And we're going to say that electronegativity is a measure of how much an atom wants electrons. And I'm going to put wants in air quotes because I don't know if atoms really want things, but I'm giving them, I'm personifying them. So they really want electrons, or certain atoms really want electrons, and some atoms don't want them as much. So we use the term electronegativity or electronegative to show how much an atom might want electrons. So if you're looking over at the periodic table, if you drew an arrow from the bottom of the periodic table, the bottom left to the top right, so a diagonal arrow, the arrow going from the bottom left to the top right, that's as you go that way, you're getting more electronegative, or your atoms are getting more electronegative. So the most electronegative atom is like fluorine. Fluorine, remember, our noble gases are stable, so they don't want electrons. They already have all the electrons they want. But fluorine is it's close to those noble gases, but it's not there yet. So fluorine's in what group? Yeah, it's in group 7A. So how many valence electrons does fluorine have? Yeah, it has 7. So if fluorine just needs 1 more electron in its valence shell to have that full octet, it's really, really electronegative. It really, really wants that 1 electron because it's almost there. So we would say fluorine's extremely electronegative. Another one that's very electronegative is oxygen. Oxygen really likes to form bonds because it really wants electrons. And we'll talk about how that happens. Okay, so now I want to get into the types of bonds. And there are other types of bonds that you'll learn about in future chemistry classes, but for our purposes, we're going to like really focus on these two, which is ionic bonds and covalent bonds. So ionic bonds occur when valence electrons of a metal atom are transferred to an atom of a nonmetal. So I want to zero in on two main ideas with ionic bonds. The first is that they form between a metal and a nonmetal. Okay, they form between a metal and a nonmetal. And then the second thing I want to focus on is that the electrons, the valence electrons, are being transferred from the metal to the nonmetal. Okay. So that word transferred is important. So the metal is actually losing electrons, and the nonmetal is actually gaining those electrons. They're being transferred. And we'll get into how that happens and what that, we'll get into it more. Covalent bonds, however, occur when nonmetal atoms share electrons to be like a noble gas. Okay, so those are between nonmetal and nonmetal. So two nonmetal atoms, right? Or more, and they're sharing those electrons instead of transferring. So one thing's not gaining and the other thing is losing. Now they're sharing, okay? So, and when these ionic bonds or covalent bonds form, atoms lose, gain, or share valence electrons in order to get an octet of 8 valence electrons. And that's known as the octet rule. So you can call that let's actually put that here. That's the octet rule. Sometimes you'll see that. So the octet rule is just saying that there is this tendency of atoms to try to get that stable electron configuration by either gaining or losing electrons or sharing electrons to get that octet. Okay, so this is just a picture of that kind of happening, and M stands for nonmetal, M stands for metal. So for ionic bonds, the metal is sharing with, or I'm sorry, erase that from your brain. In ionic bonds, the metal is giving its electron to the nonmetal. And the nonmetal is like, wee, I want the electron, that's great. And in covalent bonds, those electrons are being shared, okay? So transfer versus share, transfer versus share. Try to like think of that in your head. Ionic is transferring, covalent is sharing. Okay. So when we're talking about ionic bonding, remember, transferring electrons. Ionic bonding can result in either a positive ion or a negative ion. So we're going to start with positive. So positive ions are when an atom loses electrons. Why would we call that a positive ion? Well, the reason for that is that if we're losing an electron, remember, an electron has a negative charge. So if we lose an electron, then we have more protons than electrons, and we have an overall positive charge. Okay? So in ionic bonding, ions form when atoms gain or lose their valence electrons to form a stable electron configuration, or to be like a noble gas. Okay, so metals in group, and I'm going to highlight this, metals in group 1A, 2A, and 3A have low ionization energies. Remember, ionization energy is the amount of energy needed to lose an electron. So if it has a low ionization energy, it's ready to lose that electron. It's okay with that. It's like, go ahead, take the electron. I don't want it. I don't really need it. It's all yours. So these metals in group 1, 2, and 3, they'll lose one or more of their valence electrons to form an ion with a positive charge. So, and they'll lose electrons until they have the same number of valence electrons as the nearest noble gas. So, a positively charged ion is, we actually have a name for that. It's called a cation. And I have a little bit of a fun way of remembering that. So, cations are positive. Positive, like cat paws. So you can remember it that way. So these are positive ions, okay? And then I don't have a fun name for negative ions, but we'll talk about those in a little bit. Okay, so positive ions are formed from the loss of electrons. So let's look at an example of this. So here's a sodium atom in group 1A. It's originally neutral, right? And it has 11 electrons and 11 protons. So when sodium atoms in group 1A lose one electron, they have the same number of valence electrons as neon. And the reason they want to get to be like neon is because it's easier for those sodium atoms to lose one electron. So let's look at sodium here. It's easier for sodium with its 11 electrons, right, to lose one of those electrons so that it's like neon, the noble gas before it, than it is to gain 7 electrons, right, this, and get to argon. Okay, so it's much easier for sodium to lose one electron so that it's like neon, the nearest noble gas, than it is to gain 7 electrons to be like argon, the next closest noble gas. Okay, so it will lose an electron. Remember, it's not very electronegative. It's on the left side of the periodic table. Not very electronegative. It's a metal in group 1A, so we see that they tend to lose an electron very easily, and then they can be more like neon and they can be happy. Okay, and when that sodium ion, and now that's called a sodium ion, right? Because it's now lost an electron and it's now got a charge, and we call things with charges ions. Atoms with charges ions. So now that sodium has a charge, now that it's lost that electron and it has a charge, notice that it has a plus here. And that's how we depict that we have a sodium ion rather than just writing it like this. Okay, so that shows that we have a charge on that sodium now because we lost that negative electron. So now we have more protons than electrons. How many more protons than electrons? Exactly 1. Why? Because I lost 1 electron. Right? I only needed to lose 1 electron to be like the nearest noble gas. You can lose more than that, and then your charge will be different, right? You could have 2, 3, and so on, and we'll see some examples of that. Okay, so the other thing I want to point out, let's zoom in here a little bit. If we look at this electron configuration at the bottom, this is before the sodium atom loses this electron. So notice we have the same number of electrons and protons, and we lose an electron. Before we lose that electron, here our highest energy level is 3. But you'll notice that after we lose that electron, our highest energy level is 2. Yeah. And the reason, so the reason that sodium wanted to lose that electron is to be like a noble gas, and also because it lost that electron, it gets this lower energy level, and lower energy is more stable. Yeah. Things that are really high energy are less stable than things that are low energy. Okay. So kind of cool. And you'll notice too, actually, you know what? Let's do that later. I have an idea for later. Okay, so we can form positive ions with a higher charge, and that just means losing more electrons. So magnesium, for instance, is in group 2A, It normally has, as a neutral atom, it has 12 electrons and 12 protons. And magnesium really wants to be like neon as well, because again, it's easier for magnesium to lose 2 electrons to be like neon than it is for it to gain 6 electrons to be like argon, the next noble gas. So it's kind of sandwiched in between neon and argon, but neon's much closer. Neon has an atomic number of 10, and argon has an atomic number of 18. So it's easier for magnesium to lose those 2 electrons to be like neon, the nearest noble gas. And so when it loses those 2 electrons that have that negative charge, each of them have a -1 charge, we form a positive 2 magnesium ion. Okay, and notice, I forgot to mention this, but notice that the plus comes after the 2 right there. That's just a convention that we use. I think I don't get too picky about it. So if I saw you wrote like +2, I'm not going to get too picky about it, but just know that that's the convention. So I'd urge you to probably start trying to write it like that. But if you can't, if you make a couple mistakes here and there, it's not going to really count against you too much. At least not in my class. Okay, so once magnesium loses those 2 electrons, it's now a positively charged ion. What do we call positive ions? Cations. Yeah, so it's a cation, specifically a 2+ cation. Okay, and notice here again, we've got in this, before it loses those electrons, our highest energy level is 3, and after it's 2. Notice now too, what does this electron configuration look familiar? It's actually neon's electron configuration. Okay, so and I urge you to pause the video and try to see if you can get neon's configuration, and you'll notice it's the same thing, because now your magnesium has lost those 2 electrons. So a magnesium ion actually has the same electron configuration as neon. Really cool, and that's why it wanted to do that, is to be like neon, to be more stable. Okay, so one more quick note. We looked at magnesium and we looked at sodium, and we saw that magnesium liked to form a 2+ charge and sodium liked to form a 1+ charge. That's actually the trend that we see in all of the group 1 and 2 in both groups. So we see that in group 1, those atoms in group 1 like to form a 1+ charge. And for group 2, those atoms in group 2 like to form a +2 charge. Sorry, 2+ charge. I'm doing it. And the reason is the same. If you're potassium, it's so much easier for you to lose 1 electron to be like argon than it is for you to gain all of these electrons to be like krypton, right? So it will. Same thing with rubidium. Rubidium's going to lose 1 electron to be like krypton rather than gain all of these to be like xenon. Okay? So it's a trend that we see in both of those groups. Group 1A likes to lose 1 electron and group 2A likes to lose 2. Okay. So what happens when we have negative ions? So negative ions means you're gaining electrons, which sounds kind of weird. Gaining, but it's negative. And the reason for that is because of the charge of those electrons. When you gain more negative charges, you're getting more negative as an ion or as an atom. So what we see is that nonmetals, like those in group 5A, 6A, and 7A, they have high ionization energies. They readily gain 1 or more valence electrons to form ions with a negative charge, okay, as opposed to metals, which like to form positive charges. And they gain electrons until they have the same number of valence electrons as the nearest noble gas, which is usually 8 valence electrons, except for helium. Okay? So let's go look at that for a second. Why would that be? So fluorine is in group 7A. So that means it has how many valence electrons? Yeah, 7. So it only wants one more. So it's really, really easy for fluorine to gain that one electron to be like neon, rather than lose all of these electrons to be like helium. Okay? So it'll gain an electron, which has a negative charge. So if it's gaining one electron with a negative charge, what's fluorine's charge going to be? What kind of negative ion is it going to form? Yeah, a 1 minus. Yeah. Okay, what about things in this column here, in this group, 6A? How many electrons do they want to gain? Yeah, they want to gain 2, right? They're in group 6A. They want to be like a noble gas, which has 8 electrons. So they're going to gain 2 electrons to be like that noble gas. Yeah. What about group 5? How many valence electrons do they have? They have 5, right? So how many do they need to gain in order to be like the noble gas? Yeah, they need to gain 3. Okay, so they'll form 3 minus charge, negative ion. Yeah. The other ones, this group's kind of weird because, right, 4 is half of 8. So it's kind of like it's easy to lose 4. It's just as easy to lose 4 as it is to gain 4. So we're kind of ignoring group 4 for our purposes, and we're really only going to focus on what I've drawn here. And then you can also put a +3 here. Or I'm sorry, a 3 plus over here too. Because aluminum especially will work with aluminum, and it has a 3 plus charge. So that's something that you want to try to remember. Okay, so let's keep moving along here. So we have a name for positive ions, and that is, yeah, cations. There is a name also for negative ions, and those are called anions. I don't have a cute little way of remembering that. Just remember that if a cation is positive, the other one is negative. So anions are negative. And I'll talk about that next part in a second. Okay, so ionic charges, group numbers. So like I said, your group number tells you the ionic charge. Only because if you have to kind of do some subtracting though, right? If you're in group 7A, or adding depending on how you look at it. If you're in group 7A, you have 7 valence electrons. How many electrons do you want to gain to be like the noble gas? Well, I want to gain 1. Okay, so that helps you figure out the charge there is a 1 minus. Okay, and again, like many things in chemistry, I don't know if I mentioned this or not. If there's no 1 there, we just assume there's a 1. So you don't have to put 1 minus. You can just put a minus sign, and we know what you mean. Okay. All right. So take a look at that on your own. And it's really saying what I already mentioned. Oops. Okay. Go ahead and do this learning check. I'm going to let you pause it and try it out, and then I will come back and help you out. Okay. So consider the elements calcium and chlorine. Identify each as a metal or a non-metal. So calcium is what? Yeah, calcium's a metal. Yeah, it's on the left side of the periodic table. We know it's a metal. What about chlorine? Chlorine's a non-metal. Yeah, it's on the right side. So state the number of valence electrons for each. Calcium, why does it have 2 valence electrons? Yeah, it's in group 2A. Group 2A. Yeah, so it has 2 valence electrons. Same thing with chlorine. Chlorine's in group 7A, so it has 7 valence electrons. Yeah. Okay, so state the number of electrons that must be gained or lost for each to acquire an octet. So calcium's a metal, right? Metals like to gain or lose electrons. Which one? They like to lose them because it's easier for them to lose those electrons than to gain a bunch of them. Okay, so they'll lose a couple, this calcium will lose 2 electrons, right? Because it's in group 2. And it'll form what charge? When it loses 2 negative charges, how many positive charges does it have? 2. Yeah. It didn't gain protons, right? If it gained protons, it would be a different element. It didn't gain protons. It lost electrons. And because now it lost 2 electrons, it lost 2 of its minus charges. It now has more protons, not this specific number, but just for an example, it now has more protons than electrons. So it's going to have a positive charge. How positive? 2, because it lost 2 electrons. Okay, what do we call a positive ion if we wanted to be more specific? A cation. Yeah. Okay, chlorine. And notice this IDE ending here. That's what we drop the INE, so chlorine went from chlorine to chloride. We drop that NE and replace it with the DE when we are forming negative ions or anions. Okay, it's just a convention that we use. So you might have heard of sodium chloride. That's because that consists of sodium ions and chlorine with a negative charge. So those are called chloride ions. Yeah, we only do that with the negative ones. Okay, we only do that with negative ions, the anions. All right. Ionic compounds. Let's pause the video and we'll come back to ionic compounds in a little bit.